So I started filming this late. Forgot to get the first half in. Got a 40-watt Coleman solar panel, and it has this rotating stand for the back. So I just zip tied a 600-watt inverter. I'd like to find a better way to mount this. I don't want to mount it to the back of the panel because the panel gets hot. This is not going to be a waterproof setup. This will be when it's on sunny days only. When I'm outside, I might try it at work at first. I got about a 3 amp hour LiPo pack here. It's just taped and wrap tied to the side. I wanted to tape it mostly, not use so many wrap ties because they put pressures on the corners. I don't want that. I have a what's up meter, pretty much. This will let me know what the solar panel is making and putting into the battery. And then this has a meter on its own that kind of lets me know it's coming out. This is my homemade charge controller. Not really homemade, but it's a step down DC to DC converter. I set it to 12.5 volts, so only charge this battery up to 12.5 volts, which gives me some headway just in case this thing goes a little over, up to 12.6 or something. But I tested it with my universal power supply all the way from 14 volts to 25 volts, which this panel will never put out 25 volts. And this stayed at 12.5 volts the whole time. So I'm about to solder this to that battery connection right there and hook everything up. I just covered, this is just an open circuit, so I covered it in electrical tape. Like I said, this is not a waterproof setup. If this gets rained on, it will most likely be ruined. It might be okay just because everything's directly under the panel, like this is going to be right up here. So it might be okay, but the dampness may wreck it. So no tall grass and no wet conditions. And we'll see how this works. I'm going to put it out on my lawn and run an extension cord from this inside to my laptop during a sunny day and see how well it works. All right, so we got a finished product, kind of finished. I gotta make it look neater, but I mean, I just threw it together to see how it works, and if it works well, I'm gonna improve it. But here's the bottom side. Everything's held together by wrap ties and tape, the professional way, you know. But as you can see, it's cloudy outside, so testing this thing is not going to be great. Let's see if you can see the voltage here. Usually if I go lower, you can see it better. Anyways, input voltage of the panel is 16.7 volts because the battery is fully charged at 12.5 volts. As you can see here, 12.5 volts. Now, still 16.7 volts. What if we plug in this 13-watt bulb? In the sun, I'm sure this wouldn't even drag it down at all. There we go. Still showing the same. Still saying 12.5 volts, 12.4, 12.5. Doesn't even show any load. Solar panel is still sitting at 16.75 volts, which is interesting. I wonder how low the battery's got to go before this step down transformer starts kicking in and putting power into this battery. Let's see here. Maybe I should get another load. I think I'm gonna get a different load. I'll get back to you guys. So, got a 100-watt light bulb in, sitting at 16.8 volts. Still 12.5 volts on the inverter, it says. And now, sorry about that, I got a text message. I just turn my volume down so that doesn't happen again. You'll hear a buzz, but that's it. So we're sitting at 12 volts on the inverter. That's because I'm running through fairly thin cord because I don't plan on pulling a lot of current out of this inverter. The solar panel has gone down to 12.12 volts, which is approximately the same as the battery. And we're pulling from this battery. Now, if I unplug this, 12.3 volts, 12.3 volts, going up 12.4, Shut the inverter off. Goes right back up to full. 15 volts there. I'm wondering if almost fully charged. Look at that. Right back up. So it looks like 12.4 volts is more or less what I got set to stay at. I kind of wanted it to be at 4.5 volts, but 4.4 volts, 12.4 volts, I mean, is okay. It'll make the battery last longer, which I'm fine with. I left a decent sized gap, so there would be no problems with heat, the battery and whatnot. I bolted this to this hinged portion instead of right on the solar panel, because the solar panel frame itself gets warm as well. But as you can see, it's almost at 12.5 volts. Even in this low light conditions, the solar panel is charging. It's only a 3 amp hour battery, so this should be able to charge this battery up in about an hour and a half, 2 hours at the most. And I got usable power. Now I'm going to run an extension cord into my house. I'm going to use this. So I have my essentially a Sol-in-One knockoff. I saw this on YouTube from a very smart fellow making these. This is a really crappy knockoff of what he has. It's just a 40 watt Coleman solar panel, a 600 watt eliminator modified sine wave inverter. There is a what's up meter. This is a 4 to 5 amp step down DC converter. So it steps down the 18 to 20 volts of the solar panel down to 12.5 volts for this lithium polymer battery, which is a 3S. So it goes up to 12.6 volts, but I have it limited to about 12.45, 12.5 volts. Then it goes through this meter. It probably won't show up because this meter is very, very faint. It's hard to see with the human eye, let alone a camera. But anyways, you hit the power, you get 12.4, 12.5 volts. It's fully charged, and this is my laptop plug. And as you can see, let's see if I can go here. You see my laptop is not charging. This is a desktop monitor plugged into my Alienware laptop, and it is not plugged in. Now we're going to plug this in and see what happens. Okay, so the voltage dropped down to 12.2 volts, and as you can see, if this thing will focus, I'm not sure if it's focused, but it says we are charging 12.2, 12.1 volts. This is a fairly heavy drain. It doesn't show up in here, so it should be about 30 watts or so, because this doesn't show until about 45 watts. But 12.1, 12.2 volts. This is approximately 3 amp hour, maybe 35 amp hour battery. I'm not exactly sure because it is from China. It says it's a 5600 milliamp hour battery, which it's not true. I'm sure it's not true. It's too small to be. It's a 3-cell. It says it's 25C, which I do believe because this came out of one of those jump starter packs. It has started a 5.7 liter V8 engine for this little tiny pack, so it does quite well. Right now it is running my laptop. It's running well, and tomorrow it's going to be charged by this 40 watt panel. It should be charged in about between an hour to 2 hours, depending on my depth of discharge. And yeah, I really like this setup. It's temporary. I got all these really rinky-dink zip ties. They're just here to hold it for now. If this setup works out nicely, I'm going to put either a piece of plywood or a piece of tin or metal or something to cover this all and mount this to properly so it looks nicer
Doesn't look so rinky-dink with all these. Like everything is literally held with either tape or wrap ties. Like it's really strong though, but still very rinky-dink. Yeah. So this is my little setup. I'm gonna be testing it to see if it performs well. Maybe I'll have to add. I have another one of these batteries. Maybe 2 of these batteries may be more suited for this application than one. But I do want the solar panel to be able to charge it fairly quickly. I don't want to be always running low on battery power. I want the batteries to be full and then cycled. I'd rather have a cycled battery in a day than only a half charged battery in a day. Alright, thanks for watching, guys. Hit the like button if you enjoyed this video, and subscribe if you want to see more.